Hey everyone, this is Mr. Bonifaci. I'm going to talk to you guys a little bit about some notes and things like that about two different things today. We'll first talk about different types of matter, different states of matter in another way. We'll talk about what makes pure substances different than mixtures, and we'll get some notes on that. And the final thing will be about physical property versus chemical properties. These notes are going to be the type of notes we're going to use a lot. You won't be able to do tomorrow's homework without having access to the stuff written down. So make sure to write down all the stuff that we talk about. So anyway, you can call it like the notes properties of matter or something like that. It's great. You don't need to write down this slide, okay? But just a little background, okay? Matter is anything that takes up mass, that has mass and takes up space. So to be considered matter, okay? So mass, remember, is kind of similar to weight, but mass doesn't require gravity, okay? So like your weight will change in the moon because it's less gravity, but you have the same amount of mass, okay? Our balances, like in a classroom, you know how they have the re-zero button? It adjusts based on gravity, and that's how that works, okay? Volume is the amount of space something occupies, okay? So something greater volume will be bigger, something less volume. So matter has both those things. Okay. So which of the following has matter? All of them do, obviously. Okay. So you just finished a little mini lab. I'm going to go ahead and stop sharing and turn on my camera, and we're going to draw some notes here, and you'll just draw them right below in your. Okay. So I'd like you to go ahead and just write down matter. And we can divide matter into three groups, okay? See all this here. Okay. Obviously, there are solids. Actually, I'll do it this way. I'll do gases. I'll do liquids. I'll do solids. You could do it in any form you want here. It really doesn't matter, okay? Now, in our lab, and this is really important here, there are two characteristics that were really important. Okay, one was volume, okay, and the other was shape. Sorry, volume and shape. Okay, and put those below them. We're going to double check you had it right from the lab. You also don't have this in your journal, which is why I really want it in your journal. So you had to use evidence in the lab. You don't need to use evidence now. I'm assuming you have that. And shape. Okay. So gases. Let's see. How do I want to work this? Let's do solid first. I'll slide over a little bit. Solids, like this bowl here, or my pen, right? Okay. Solids, do they have a fixed shape? Yes. So you can write fixed here. Fixed. The shape's not going to change. Clearly, if I take the bowl and smash the bowl right here, it's going to change its shape. But without a force, it's going to stay the same shape. Okay. So volume, okay, same deal. It's also fixed. Okay. Even if I smash it or stretch it or whatever else, it doesn't actually get bigger. It just rearranges the shape more than that. And that all again just takes pressure. Okay. Liquids, like I have something right here. Okay. So you'll notice, and I can't do a good example here, but a water bottle, whatever. If you turn the water bottle, it maintains the same volume. The liquid, no matter how you turn it or pour it or whatever else, doesn't get bigger or smaller. It maintains the same volume, but the shape is changing or variable, whichever you want to call it. Variable, remember, means changing. Right. Okay. So gases, of course, can change shape. You could imagine that. Right now, to view moving, I'm changing the shape of the gas in the room as I move around it. Right. I'm changing the air in the room as I move. So it has a definitely variable shape, and it has a variable volume. A good example of that is a balloon. Right. Air in a balloon is balloon shaped, right? But if I squeeze it, the pressure increases, but it's a smaller volume. Okay, so its volume can be variable too. Okay. Another great example is I take that same balloon And imagine if I took it into a room, but the room had no air in it. It was a void. Okay, it's empty of stuff, right? And if the room was a void and I popped the balloon, the air in the balloon would actually spread around the room evenly. It'd be really, really low pressure, but it'd be equally spaced around the room. It would take the shape of the room if I popped it. Okay. So the last thing I want to add here that makes it would be I'm going to write it this way. Particles have strong attraction to each other. So in a solid, and you saw this before, the particles are really attracted to each other. That's what holds the form right there, okay? And in gases, there is weak to no attraction between particles. And I'm using the word particles because it could be atoms, it could be molecules. So okay. So for liquids, okay, this you could say like medium attraction. And I could write more about it, but that's enough. You get the idea. Medium attraction. Okay. So hopefully you have that down. If you need to pause that, you can pause it. Okay. But that is enough here. I'm going to go back to my screen share here because I wanted to share a little bit more with you. Okay. So again, solids, you'll notice here, they're very organized. They're very organized. You could add that word if you want to do. And you'll notice there's a strong attraction between them. There's a fixed volume. There's a fixed shape. Liquids here, they're going to get smaller, so they're going to be the same volume. Like no matter how I pour that there, it's going to be the same volume of liquid. However, what's going to happen though is that those particles are going to rearrange into a different shape. Gases are free flowing. Okay, they're bouncing around in here, bing, 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 bing. And by them bouncing around in here, what's actually going on is their volume could change. If you give them a bigger beaker, they take up that bigger beaker. And their shape's constantly changing. You could put them in a balloon shape or whatever else. I mean, their shape is whatever it is. So, and you can see some examples of the different things above right there. Okay. So back to our note, I want to talk about different types of substances now. Okay, so we're going to skip down here. I'm going to draw a line in my notes just to make sure I know this is definitely separate right here. I'm going to write down matter again. And matter can be broken down into several other forms too, or other ways of talking about it. So obviously this is gases, liquids, and solids, but we could also divide it into two categories. You're going to need at least a half sheet of paper here. So if you need to go to the next page or whatever you need to do to make sense. Okay, we're going to divide it into pure substances, and we're going to go ahead and put this in mixtures. Okay, so, and we're going to write same composition of particles throughout. So it means all the particles in there are the same stuff, whatever that stuff is. And I'm going to use the word mix again because I think you get it. I could use variable again, but if you want to, but you could say a mixture of different types of particles. Okay. Now, each of these are actually broken into different categories. So a pure substance, there's actually two types of those. And one is called an element, which is what we're going to be talking about a lot in our next unit. And the other one is called a compound. And a compound is very similar to a molecule. You can think about them as similar words. There's actually some slight differences, but at this point, they're the same thing. That's fine. And I'm going to say element is all the same type of atom. And a good way to think about that is they're all this, like on the periodic table that we looked at in the first week, they're all carbon or all oxygen. They're all the same type of atom. Okay. So, and these ones here are atoms bonded to each other. So some good examples here would be like oxygen, carbon, iron, right? Compounds or molecules could be things like NaCl, which is salt, or water, H2O, or sugar, C6H12O6. So anything like that. There are also two types of mixtures. Okay, there is homogeneous, okay, and there is also heterogeneous or heterogeneous. Homogeneous and heterogeneous is how you say it, but I'm highlighting the front part of the word because it's going to give us a hint. Now, for those of you in bio last year, which I think is many of us, you remember how we talked about like homosexual, heterosexual, and we had homozygous and heterozygous for genetics. So remember that this means same. So if you're homosexual, you're interested in the people of the same gender. And if you're heterosexual, you're interested in people of a different gender because hetero means different. Okay. Okay. Now, so this, a good way of describing it, what this means is same, same arrangement of particles all the way through. Another way of saying that is evenly mixed. So then it's really evenly spaced the whole way through is the same, right? Homogeneous. Okay. You may have seen that word on milk. Homogeneous milk is the same mixture the whole way through. Okay. Hetero is different mixture throughout. So that might mean one side has more of this type of particle and the other side has less of, as it says, not evenly mixed. Not evenly mixed. So let me show you some good examples because I think that helps. I'll share my screen again. Okay. So this is the rest of that stuff there. We saw that. Okay. So matter, right? There's pure substances. Remember, pure substances are same compound, same particle, they're same, okay? So here's an example of an element. That element is gold. Here's an element. Here's an example of a compound or molecule. This is water, okay? Notice that these are all the molecule that has one blue and one yellow, whatever molecule that could be. Maybe it's carbon monoxide, one carbon and one oxygen. Carbon monoxide would look like this. But notice that they're all the same, and this is a compound here, and they're all the same particle. Okay. Over here are mixtures. They're not the same particle. Okay. So notice here there's blue particles and yellow particles. They're not the same particles, not evenly mixed the whole way through. Okay. There's two types of mixtures. Homogeneous. Good example here is if you stir the batter really, really well, assuming it doesn't separate, it would be homogeneous, evenly spaced the whole way through. Okay. Homo means same mixture. Okay. Down here is a mud puddle. That's a very good example of heterogeneous. On top, there's water. On the bottom, there's whatever the mud particles are made out of. So it's not evenly spaced the whole way through. So it's heterogeneous, okay, in that same way. Okay, let me go turn the camera back to see me because we have more to do, but you don't need to see me draw anymore. Okay, so here's a good example of our chart that we just drew. Notice that matter is divided into pure substances and mixtures. And that pure substance could be element, like one type of element, whatever it is, or compounds. And this could be like water or carbon dioxide or something like that. Mixtures are homogeneous mixtures, which means they're evenly spaced. Notice that these are a mixture of the 2 green and the 1 orange, and they're evenly spaced. Or it could be heterogeneous. Notice that the probably water molecules are above whatever the other ones are. Here's another good picture of that same type of thing. Element, same, atom all the way through. Compound, you'll notice here, in this case here, they're all the same compound. It probably is water or something here. Here is an homogeneous mixture. So these are mixtures, homogeneous. Notice that it's evenly spaced the whole way through. Here's a heterogeneous mixture. Notice there's certain parts that are more of this type, other parts that are more of that. Hopefully that helps you make sense of it.